going to begin this next unit by doing a recap of all the things you've learned about quadratic relations so far, and then we'll add in a few new things too. So I want to begin by comparing three different forms of quadratic relations: vertex form, standard form, and intercept form. Sometimes it's called factored form as well. And if you haven't clued in why it's called factored form, you'll start to notice that there's a relationship between this and this by factoring, and we'll explore that more in this unit. So in vertex form, we've learned that there are a number of pieces in here that can tell us some things about what this particular parabola might look like even before we begin to graph it. So for example, if we look at the value here in front of the bracket, we don't see anything. It means it's plus 1. So we know that A is equal to 1, so there's no stretch or compression factor. And we know that it's upward facing because it's positive. And when we also look here at whether something's being added or taken away from X, we know that this has to do with the left to right shift, if you will. Now X plus 2 actually means that it goes to the left by 2, or there's a shift in that direction for the whole parabola. And then this minus 1 in the end moves the parabola up or down, and since it's negative, we know that it's been shifted down by 1. And so I just want to write these down just so that we can kind of recap the big ideas. If we were to try to come up with a sketch of it right now, we could do it based on comparing it to our friend y equals x squared. And we know that this parabola would have the same type of shape, same curvature because it has the same a value, and it's upward facing as well. But this particular equation right here would be shifted to the left 2 and down by 1. So to the left 2 and down by 1 means that it might look something like this. And it's always good to have a comparison to y equals x squared so you can see how they're similar and how they're different. And we can probably, get a reasonably accurate sketch from that. Okay, we could also label this vertex here as being -2, -1. And that's really all the level of detail we could put on here. I'm going to go to standard form. We haven't done a lot of work with standard form, but we will be in this unit. When we look at this, what do we know about the parabola? Well, like all of its friends, it has an x squared term in it. This one doesn't, looking at it, but if you were to FOIL it out, you would get your x squared term. That's what makes all of these quadratics. We see the a value is also 1, so there's no stretch or compression factor. We see that, again, that value of 1 is positive, so it's going to be upward facing. And then what else do we know in terms of key features? Well, do we know anything about the vertex from here? No. Do you know anything about x-intercepts from here? Sadly, no. The only thing we could pull out of this is recognizing that if we were to let x equal 0, which is the case for any y-intercept, this term and this term would disappear, and we'd be left with y equals 3. So we know that the y-intercept would be 0, 3, just by doing some mental math of putting 0 in here or recognizing these terms would disappear. So if I'm going to draw a sketch of this particular quadratic, I'm going to put in again sort of my rough sketch of y equals x squared here. And the only thing I know about this one is it has the same amount of curvature and it's going to cross the y-axis at 0, 3 right here. So I don't know if it's shifted up or down, but I know it's going to cross through either this way or this way. So sadly, it's hard to make a sketch when a quadratic is in this form. Well, let's try doing intercept form. So what do we know about this before we sketch it? Well, again, it looks like it has the same a value. There's a 1 out in front of here, and it's positive. So we know that a is equal to 1, no stretch or compression factor. I'm going to put S/C for that. We know it's upward because it's positive. And then we had learned in the last unit that these guys here are the x-intercepts. Because if y is going to be 0 in this equation, we have to somehow let the right side also be 0. As long as one of these terms, because they're being multiplied, is equal to 0, the whole right side will be 0 too. So there's two ways to make the right side of this equation 0. We could let this bracket be equal to 0, and we could let this bracket be equal to 0. The only way this one becomes equal to 0 is if x is negative 1. The only way this one becomes equal to 0 is if x equals negative 3. So we know that we have some x-intercepts of negative 1, 0 and negative 3, 0. So could we sketch the parabola for this one, knowing that information? Well, again, we always put on our y equals x squared sketch as a reference point. And we would have y-intercepts here at negative 3, 0 and 1, 0, or negative 1, 0. And we know, therefore, that the vertex has to be a dead center between those. This is not hard to figure out where the middle is. It has to be at negative 2. And if I put negative 2 into this equation, I can figure out what the value of y is at the vertex. Let's see if we can do it mentally. If I put negative 2 in here, this term will end up being negative 1. And if I put negative 2 in here, this will be positive 1. So negative 1 times positive 1 means y would be equal to negative 1. So the vertex would be negative 2, negative 1, and we know that it's about the same amount of curvature as our y equals x squared friend. Okay. So we're able to do sketches based on different pieces of information that we've received immediately from the equation. So the question then becomes, what happens if we graph all three of these together on the same thing in Desmos? Now, this is a little tricky for me to do on video, but I'm going to try to show you. I've done it on my phone. This curve right here is all three of them. See? I've got them all listed there. And they end up, interestingly enough, all being the exact same parabola. You can see that there's some key features. There's your vertex of negative 2, negative 1. Here are your x-intercepts of negative 3, negative 1. And remember standard form, how we found the y-intercept? There it is, 0, 3. So isn't it interesting that sometimes a parabola can be expressed all three ways? And again, we'll explore throughout this unit when that can and can't happen. So I just wanted to show you that we ended up with the same parabola. So let's summarize again in the table you have in your notes what the key things are. And I've kind of done that here already too, so you can fill it in as we go. So we know the general equation for a quadratic is y equals a times x minus h squared plus k when we're looking at vertex form. When we're looking at standard form, this one's a little new for you, and I'm going to show you what it looks like. It's new, but it's not. Let me show you what I mean. It's ax squared plus bx plus c. Now, you might not used to be seeing the y in front of it, but if I take it away, that's the basis for our factoring unit in Chapter 5. So we're going to bring back some Chapter 5 principles in here too. And then, for intercept or factored form, we have y equals a times x minus r times x minus s. And you'll notice in these general formulas, when you see a negative in it, like here, negative r or negative s or negative h, that's kind of a clue that, again, remember, what you see is opposite to what you get. So we saw plus 1 and plus 3, but the x-intercepts were actually negative 3 and negative 1. Or here we saw negative h, so even though that says x plus 2, which we think means